Hi friends, Miss C here. We finished most of this page in class today, so we are going to pick up on example 3. I'm going to do number 1 for you guys. Example 3 talks about understanding inequalities with infinitely many or no solutions. So just like with equations, inequalities have the same options where you can have inequalities with infinitely many or no solution options. So we're going to first take a look at number 1. And our first step whenever we are dealing with inequalities or equations is to look for the distributive property, which I see. So I see negative 3 times 2x, which is negative 6x, and negative 3 times negative 5, which is positive 15, is greater than negative 6x plus 9. Now I need to move the things with the variables onto the same side. Missy always likes to move what's on the right to the left. So she's going to do the opposite of a negative, which is a positive. So I'm going to add 6x on either side. And if I have two of the same thing and they are opposite signs, they cancel out. So those go away, and so do those. Both of them cancel out, just kind of like they did in equations. So I end up with 15 is greater than 9. Now we need to ask ourselves, is this true or false? We don't know. We have to ask ourselves, which one of these? Is 15 bigger than 9? I would say yes. So this is true. So that means there are infinite, can't spell, many solutions. And that's it. We've answered this. Both of these guys are your answers. If you would like to pause and try number 3, please do so. I'm going to meet you on the back side. Okay, now we're on the back. Let's check and see if this number 2 has infinitely many solutions or no solution. So I end up with 4x minus 5 on the left, and then I see the distributive property on the right. So 2 times 2x, which is 4x, and then 2 times negative 3, which is negative 6. Then I always like to move the variables onto the left. I see that this 4x is positive, so the opposite is positive is negative, so I'm going to subtract 4x on either side, and my 4x's cancel out, and I'm left with negative 5 is less than negative 6. And again, we have to ask ourselves, is this true or false? Well, which one is bigger, negative 5 or negative 6? If I'm looking at my number line, negative 5 is here, negative 6 is here, and negative 4 is here. Would you rather owe $5 or owe $6? I would like to owe as little as possible. So this guy is actually bigger than 6. So this is a false statement. And so that means this has no solution. So if you get something that's false, it's no solution. But on the other side, if you get something that's true, it's infinitely many solutions. And there has to be no variables left over. Okay? So go ahead and try number 4. This is your try it. And number 2 on the other side was your try it as well. So make sure you get that one done as well. We'll go over the answers in class. And then you need to try chunk summary number 3. And then go ahead and write a connection, which it's easy to do for a connection because you guys have already done no solution and infinitely many solutions in equations. So you should be able to make a connection, but if not, write a question. And then meet me in example 4 for a word problem. Yay! All right, back for example 4. We see that Derek wants to order some roses. For what number of roses is it less expensive to order from florist A or from florist B? All right. And it doesn't really give us any numbers here because it wants us to look in this picture. So if I'm looking at this picture, I see that florist A charges $4.75 per blue rose plus $40 delivery charge. And florist B charges $5 per red rose plus $25 delivery charge. So when I set this up, I'm going to have the cost of the blue roses and then we want to know when it's less expensive for florist A. So the sign for less expensive would be less than. And then we want the cost of X florist B, where X just stands for roses. So if you need to write that on the side, X equals roses, just to make it easier for us to know what X stands for. So let's go back to this picture and come up with our expression. So if I'm looking at the blue roses, I see that florist A charges $4.75 per blue rose, and we said that R stood for rose, so $4.75 R plus $40. And then for our florist B, they charge $5.15 per rose, so R plus 25. Now we're going to come back to what our setup is, and I'm going to plug in those expressions for what I wrote down as an equation. So I'm going to get 4.75 R plus 40 is less than, and then the $5.15 R plus 25. All right, now all I gotta do is move things around. So I'm going to move the 5.15R just because it's out of habit. I always move this stuff from the right to the left. You don't have to, but I always do. And when you subtract those, let me get my calculator out because I am not a human calculator. You do 4.75 minus 5.15, and I get negative 0.4 R. And then plus 40 is less than, and then the 25 is still on the other side. Now I'm going to do the opposite of addition or subtraction. So I see addition, I'm going to subtract 40 on either side. And then when I subtract 40 on either side, I get negative 15. And then we get that less than there. And then I need these cancel. And so I get what's left over, this negative 0.4 R. Now I need to do the inverse of multiplication, which is division. So I'm going to divide everything by negative 0.4, negative 0.4. And I'm dividing both sides by a negative, so what's going to happen to my sign? It's going to flip. So instead of a less than, I now have a greater than. And now I have R is greater than 37.5. There we go. Okay. So the solution is all real numbers greater than 37.5. However, you can't buy half of a rose. You have to buy a whole rose. There's no buying half of a rose. Okay, so our actual solution is, and I'm sorry if you guys ran out of room, but I'm going to write it over here because I ran out of room. So make this fit somewhere in your notes. If Derek plans to buy 38 or more roses, then florist A is less expensive. Because we know that R, if it's greater than 37.5, then the other company is going to be more expensive. However, if he buys 37 or fewer than florist B is less expensive. And if you get confused on which one, you lose track of which company you were talking about. We set this up in terms of florist A, right? Our word problem says, for which number of roses is it less expensive to order from florist A? So we put cost of florist A is less than florist B. So when we talk about our answer here, when we're talking about florist A, we know that whenever it's 38 or more, because R is being eaten by the alligator, whenever it's 38 or more, it is more expensive, or it's less expensive to order from florist A, and it's more expensive to order from florist B. That means everything lower than 37 is the opposite. So these are your two answers to your two questions that it was asking you. Okay, we'll get some more practice on that, I promise. I want you to go ahead and try number 2. It is going to add some stuff to it. So it's changing the florist B. It's increasing the cost per rose to $5.20. What is the number of roses for it to be less expensive to order from florist A or from florist B? So it's still asking the same question. So I'll help you set it up. Florist B is increasing. So instead of it being $5.15, it's going to be $5.20. So florist B is now $5.20, still plus the 25. Oh, I forgot the R. And it's still going to be less than. And then we're going to have the cost of florist A on the other side. And it didn't say anything changed about florist A. Well, florist A is still staying 4.75 R plus 40. And I want you to do the rest. Okay? All right. I will see you tomorrow with my initials. Bye.